All right, hey everybody. And now in this video, in this section, we are going to start working on authentication and authorization for our application. Now, when we start authentication and authorization, the first thing you may think is inside our main.py file, we're just going to create more API endpoints now for users, which will take new user requests where we have to validate authentication and authorization. But we may not want to mix all of our authentication and authorization logic with our to-do logic. That'll start just making a bunch of logic that does not intersect with one another on the same file within our FastAPI application. Now that our application is growing, we now want to look into how do we scale our application for cleanness and for maintainability. So the very first thing we want to do is inside our to-do app, we're going to right click and say new Python file, and we're going to call this auth.py. Now inside auth.py, we need to go ahead and just do our normal FastAPI setup, where we want to go ahead and just say from FastAPI, import FastAPI, and then we want to go ahead and say app equals FastAPI from our main.py, but add the same logic within our auth.py file. Now, underneath this, we can go ahead and just create a FastAPI endpoint. And this is just for a demo purpose. So I'm just going to say app.get/auth, where I'm going to say async def get user, and then return a dictionary of user authenticated. Now, let's check this out. If we go into our terminal now, and inside our terminal, we say unicorn main:\app -- reload. And we open up our browser and refresh the page, we can see that we still get all of the API endpoints that are sitting in our main.py to-dos file, but we do not get our new API endpoint that we just created with our auth.py file. And this is because our auth.py file is technically a different FastAPI application. And that's because right here we said create a new app of FastAPI. Now, we do not necessarily want to create an entire new instance of FastAPI where we have to go inside here and say unicorn auth:\app -- reload. Because now if we go ahead and do this, and we come back to our application and refresh, we're going to see our new auth API where we can try it out and execute and get user authenticated. But now we can't call any of our to-do application endpoints because they're hidden under our main.py file. So now that we created our auth.py and our main.py file, I'll see you in the next video where we learn about routing and how to scale this application so we can maintain and make it significantly cleaner. In the last video, we were able to create our auth.py file where we returned user authenticated, but the issue was that auth.py needs a separate port to run than our main.py file. And we were looking for a solution on how we can scale our main and auth.pys so they can run on the same port but allow our FastAPI application to really be able to be scalable and maintainable. Well, in FastAPI, we're going to be using something called router. Now, router is a way for us to be able to have a main file, the root of our application, and then what sits on top of the main file are all these different routes, which will lead to different FastAPI files, which will have their own APIs and API endpoints. Now, that is exactly what we want. We want to have our own todos.py file with todos APIs, and we want our own authentication or auth.py file with authentication and authorization API endpoints. So the very first thing I'm going to do is right click on our to-do app and say new Python package, where I'm going to name this routers. And now inside routers, I'm going to grab my auth.py file and drop it inside our routers package. When you do this, it's going to ask, hey, do you want to refactor your auth.py file to now be inside routers? And we're going to say yes, refactor. So now if we go into our auth.py file, our auth.py file is going to sit inside our routers package. And now what we need to inherit from FastAPI is something called API router. Now, API router will allow us to be able to route from our main.py file to our auth.py file. And we can do that by, instead of saying app equals FastAPI, we want to say router equals API router. And once we do that, we can remove this import of FastAPI. And now we want to go ahead and grab this router variable, and instead of saying @app, we want to say @router. Now that our auth.py file is a route instead of just the entire application, we can now go to our main.py file and make sure we include the auth.py file as a route of this FastAPI application. So right under this models.base.metadata.createAll, I'm going to go ahead and say app.includeRouter. And now inside, we need to list our auth.py router, which is just called router. So what we need to do is go ahead and import from our routers package our auth. So let's go ahead and say from routers import auth. And now inside our app.includeRouter, we want to go ahead and say auth.router. Now if we run uvicorn main:\app-reload, and we open up our browser and we refresh, we can now see that we get our authentication route on top of all of our to-dos routes. So what we're really doing is our main.app is going to say all of these API endpoints need to be ran on our application, and anything that is included as a router. Alright, so in the last video, we went ahead and created this routers package with our auth.py inside. And then we have this main.py file that references this auth.router inside this app.includeRouter. Now, one thing I want to do in this lecture is create a new routers file called todos.py. So let's go ahead and just right click on routers and say new Python file and call this todos. Now our todos.py is going to need everything that our auth.py has of this router equals API router and from FastAPI import API router. So let's hop over to our todos.py file and let's go ahead and just paste that in. Now before we continue, there's one thing that we need to do to be able to continue on. Currently, our parent file or our parent directory is this FastAPI directory that has our FastAPI environment inside. And then one step lower, we have this Python package of to-do app. Now, PyCharm is going to have a hard time finding relative path locations when we try and import certain areas of our application. For example, if we try and import database from our auth.py file, we might get some issues because we're not actually in a Python project, we're in a directory which has a Python project inside. So the next thing I'm going to do is just go over here in PyCharm and say File, Open a new project, and inside here I'm going to go into our FastAPI application, and I'm going to go inside our to-do app and open the to-do app as a new project. I'm going to say this window. So now our to-do app is going to be the parent location, not the FastAPI directory. We are still going to have our FastAPI environment running, and if it's not, you know just to go up one more directory where our FastAPI environment is to start it up. And now from here, I'm going to go into my main.py file, and I'm just going to start by copying everything from our main.py file and pasting it inside my todos.py file. And I'm just going to override everything we put in here before. And now inside our todos.py file, I'm going to go ahead and say app is now router, which is going to equal API router. And instead of FastAPI, let's go ahead and change this to API router. We no longer need this app.include router or this models.base metadata. But what we can do is we can erase this engine import, remove from routers import auth, and remove this import models. Now what we want to do is go through all of our API endpoints and change app to router. All right, now let's go to main.py file. From routers import auth, we also now want to import to-dos, which is our new router file. We then want to say app.include router of our to-dos.router. After we add that, we can go ahead and delete everything else in our main.py file. And then delete all of the unneeded imports that we currently have in our application. So now we have our main.py file, which will create a new database if it doesn't exist, which is a FastAPI application. And now instead of creating our API endpoints right here in main.py, we are saying we want to make these API endpoints from our routers, which are auth and to-do. So in our auth, we have one API that just auth that just returns a user of authenticated. And in our to-dos.py, we have all of the to-dos that we are creating beforehand. But instead of using app equals FastAPI, we're using router equals API router. And then we have our dependency injection, and we're calling all of our API endpoints from here. So now if I go into my terminal and I say uvicorn main:\app -- reload, we're going to get a successful startup. We're going to open up our browser, refresh the page, and you can see that we still get our auth, where if we execute it, we're going to get authenticated. And if we use our get all API endpoint, we're going to get all of our API endpoints. So what we really did here was we just cleaned up our application for scalability and maintainability. We now have our main file, which is just in charge of starting up our FastAPI application and grabbing these routers. And inside our routers Python package, we have auth.py and our todos.py. Both of these are holding API endpoints. So we can start creating multiple Python files, each with their own distinct functionality, and then be able to combine them into our main.py file. So doing this makes us one step closer to be able to implement authentication and authorization within our application. And I will see you in the next video. Hey everybody, and welcome back to another lecture with Coding with Roby. And in today's lecture, we're going to be going over one-to-many relationships.
So what does one-to-many really mean when talking about SQL tables? Well, when it comes to our application, this means a single user can have multiple to-dos. However, a to-do cannot have multiple users. Therefore, if you are a user, you can have one to-do to take out the garbage, one to-do to get a haircut, one to-do to take a shower, and one to-do to take out the garbage. Just like that, you are one user who has multiple to-dos. Now in our application, we can have multiple users, each with a bunch of to-dos for themselves. So one-to-many does not mean there can only be one user, period. It means that there can be multiple users, and each user has a group of to-dos. To just take a step back, I want to show you that there are two separate tables going on here within our database. One of the tables is dealing with users, which includes having an ID as a primary key, and email, username, first name, last name, hashed password, and is active. The other table is the to-dos, which includes an ID, primary key, a title description, priority, and complete. However, in this setup, how do we connect a single user to many different to-do records? Well, we'll have to modify our to-dos table just a little bit. To do this, we need to add some additional field to the column of our to-dos table. This new field will be called owner. As we can see, the owner has an FK in parentheses, and this means foreign key. We have a video explaining what foreign keys are, but to keep it simple, it holds the primary key of the user record, so we can locate that specific to-do by the user ID field. If we go back to our two tables, the one with the user and the one for the to-dos, we can see that we need to add a new column to the end of our to-dos to now include a foreign key. This will make the to-dos now have an ID as a primary key, a title, description, priority, and complete, with a new field, which is a new column that is the foreign key called owner. Let's bring back our 6 records of our to-do data we had in our application, along with the 2 records of our new users, which we'll be creating in a future video. Here we can see that we have 2 users, the first one having the ID of 1, email is coding with Roby, first name is Eric, last name is Roby, the hashed password is a long sequence of scrambled letters and numbers, and is active is true. Our second user is just going to be an example user, so it's going to have a whole bunch of fake data just so we can have multiple users. But now let's take a look at the owner column on the to-dos table. They now have different 1s and 2s labeled throughout all the records. This is the foreign key doing its thing. The foreign key for the to-dos is listing back to the user. So we know all to-dos with a foreign key of 1 belong to coding with Roby, while all foreign keys that have an ID of 2 relate back to our example user. Pretty cool, right? Alright, well, this wraps up this lecture, and I will see you in the next video. Hey everybody, and today we'll be discussing foreign keys and how we can use them within our application. Okay, so this brings us to the question of what is a foreign key? A foreign key, usually referenced by FK, is a column within a relational database table that provides a link between 2 separate tables. A foreign key references primary key of another table, and most relational databases need foreign keys to be able to link tables together to present a sequence of data. And in our small project, we'll be linking our to-dos to a single user. And since it will be one user to many different to-dos, this relationship again is called a one-to-many relationship. Let's see some more information about foreign keys. For example, let's pretend we did a select all from our to-do SQL statement. To reiterate, this means we are selecting all columns and rows from the database. And since we're selecting all rows and columns, we are getting our database table of our to-dos. However, this time there's an additional column that we added called owner, which is a foreign key. This is just so we can see what information in our to-dos for this example. All right, let's go ahead and do the exact same thing with our users. We're selecting all from users, which will display all columns and rows for our users table. Now, one thing we can notice is that our users table does not have a foreign key column. We are only referencing the to-dos back to the user, due to being one-to-many relationship. You may be asking yourself, how would you reference the users from the to-do? Well, to start, each API request, a user will have their ID attached. In a future video, we'll be able to find the user ID from the JWT, which is a JSON web token that we'll be extracting. But for now, let's just keep in mind that each API will have a user ID attached when we're requesting to-dos. If we have the ID attached to each request, we can use the ID to find their to-dos. So again, just to reiterate, we can have our users table, our to-dos table, in the owner's foreign key column referencing the user's primary key. So awesome work. This is how we're going to be referencing the data between the tables. So how do we write a SQL statement to reference this data? Well, remember, we will have the user ID on each request. So that skips an entire step of us having to query the user's table. We can do all of this with just a where clause. So select all from to-dos where owner is equal to 1. This will select all rows and columns where owner is equal to 1. Therefore, this will result in returning all of the to-dos that align with the users whose primary key is 1. If we change the statement a little bit, we could also say select all from to-dos where owner is equal to 2. Again, this selects all rows and columns where owner is equal to 2. This results in getting all of the to-dos from the user with the primary key of 2. So awesome work. This wraps up the lecture, and I will see you in the next video where we're going to start implementing what we learned.
Hey everybody, and now in this video, we are going to enhance our database to now have a new table for users, so we can be able to create users inside our database. Now, the very first thing is this todos.db. This is kind of a confusing name because we have our to-dos database, and inside our to-dos, we have a to-dos table. So first, let's go ahead and just change this name of to-dos database. So let's go into our database.py, and right here where we create our SQLite database, let's go ahead and just say to-dos app. So now we're going to have our to-dos app database with two tables inside, one called to-dos and one for our users. Like I've mentioned before, SQLAlchemy cannot enhance a table for us. It can only create a table for us. And you can enhance a table using something called Alembic, and we'll use Alembic later on in this course. But for right now, let's just go ahead and delete this todos.db by right-clicking and saying delete. And we want to make sure all of these are checked and then say OK. So now when we run our application, SQLAlchemy will create a new database for us. But before we create a new database, we want to go inside our models.py file. And let's change some stuff around so when we create our new database, we're going to have an updated to-dos table, our updated and new users table, and we're going to have that new database name. So the very first thing we want to do is right above our to-dos, let's go ahead and just create a new class called users. And just like our class to-dos, users is going to inherit base. And right under this, we need to name our new table. So we can say underscore underscore table name underscore underscore is equal to users. So we're going to have a table called to-dos and we're going to have a table called users. Well, just like our to-dos, our users are going to need some columns for data. It's going to need a ID, which is equal to column. We're going to say it's an integer, and it's going to have our primary key, which is equal to true. We also want it to have an index that's equal to true. So both our users and our to-dos are going to have a primary key called ID, which is indexable. We then want to say users will have an email of column string. And here we want to add some more properties. We want each email of users to be unique. So we can say unique equals true. We want a user to have a username as well. So we can say username equals column string, and we also want this to be unique. And then a user can have a first name that is of column string, a last name that is of column string, a hashed password, which is equal to column string, is active, and we're going to say equals column of type Boolean, and just like we did in to-dos for complete, we're going to say default, but instead of saying false, we're going to say true. So when a user's created, we're going to default them to being active. And then we're going to say role equals column string. And now we need a way for our to-dos to be able to reference a user, or for a user to be able to reference to-dos made by that user. So let's go down into our to-dos table, and at the very bottom, let's go ahead and just say owner underscore ID equals a column of integer. And this is going to be the foreign key that references the user. So we can just say foreign key and then users.id. What this means is when a to-do is created, we need to now reference a user's primary key inside this to-do. So when a user logs in, we can grab their primary key, which is unique, and identify all the to-dos in the to-dos database where the owner ID matches this ID. That means that to-do belongs to that specific user. And we need to import foreign key from SQLAlchemy. So right after Boolean, let's just go ahead and say comma foreign key. All right, so let's go over this table one more time. We're going to create a new class of users that inherits base, and this is just all from our database. We need to create a new table name, which is called users. We're going to have an ID of a primary key for that user. Each user is going to have a unique email and username. Each user is going to have a first name and last name. Each user is going to have a hashed password, and now a hashed password is a password that is hashed. So what hashing means is we are more or less encrypting a password that we cannot de-encrypt. Therefore, when a user types in a password, we hash the password where no one knows how to de-hash the password. So we're just going to get a long list of random characters that we save in a database. Now, the way that we can verify a user is if they type in the same password. So let's pretend the password is test1234. When test1234 comes in, we rehash the password and we compare it to the hash password in the database. This means there's no way for a dev to be able to see the password of a user, or if the database gets hacked, there's no way for the hacker to see the password because it's always going to be hashed. And the way that we verify a user is we just compare two hashes instead of the actual password in text. And I'll show you how to do this step by step. We're also going to have a isActive, which will show if a user is active or not, and a deactivated account will not be able to fetch their to-dos. And then we're going to have role, whether the user is a admin or not an admin, and we'll make some special API endpoints for users that are admins. And then we added owner ID within our to-dos, and our owner ID column will be the primary key of the user ahead. So when a user can sign in, we can grab their ID and then go fetch all of the to-dos from the to-dos table where the primary key of that user matches the owner ID within the to-dos table. All right, so now let's go to our project and let's open up our terminal and say unicorn main:\app -- reload. When we run this, we'll get an application startup complete. Now, if we click on to-do app, it'll create our new to-dos app.db. And inside our to-dos app.db is going to be the new tables that we just created. Now remember, we did delete the original to-dos.db. That database had all of our previous to-dos, so all of our previous to-dos are now gone. So we're going to have to create all these from scratch again, but that's okay because we enhanced the original to-dos table and we created a new table. So we're just going to go ahead with authentication, and when we have users created, we'll then go ahead and create to-dos that are from a specific user. So our application is moving one step forward into becoming a professional application, and I'll see you in the next video. All right, in this video, we are going to start enhancing our auth.py file. So let's go ahead and jump into our auth.py file where we have this router.get of /auth where we just return a dictionary of user authenticated. Let's go ahead and just change this to a post. So this is now a post request method. And let's go ahead and just change this to create user. All right, so before we get started with what we should do inside this new post request method, let's go ahead and right above here, let's create a new Pydantics class, which will be able to do some field validation on creating a new user for our application. The very first thing to do, let's go ahead and say class create user request from base model. And as always, base model is going to be red because we need to inherit it from Pydantic. So if we just hover over this and say import this name, we can see Pydantic base model, which will add to the top of our file from Pydantic import base model. All right, and now inside here, we want to say username of type string, email of type string, first name of type string, last name of type string, password of type string, and role of type string. So the two fields that we're leaving out is the ID, which we're going to have FastAPI and SQLAlchemy auto increment for our primary key, and is active. And we'll just say every time we create a new user, that user is active by default. So all of these are pretty self-explanatory with username, email, first name, and last name. But our password is just going to be a text-based password for right now, so we're not going to include the hashing. And role is going to be the role of the user. All right, so now let's just scroll down, and inside here, let's go ahead and just add some code right above this return statement. And inside the parameter first, we first need to pass in our new create user request. So here we can just say create user request of type create user request. All right, so we're going to be able to take in our user, and now we want to make sure that this user is going to equal a user and our model. And our user model is going to be the user information that we created for our table. Just like previously when we were using to-do models to be able to query databases, we're going to do the same thing with our table. So if we look into our to-dos.py, we can see that we say from models import to-dos. We're going to say the same thing but users within our auth.py. So let's go to the top and just say from models import users. Perfect. So now just say create user model equals users. And typically how we've been doing this before is inside here, we've been using the dictionary. So we'd be doing something like create user request dot dictionary with 2 asterisks in front. But unfortunately, this will not work. The reason being is our create user request has a password, while our models does not have a password, it has a hashed password. So if we run the application, we're going to get an error when this tries to get created. It'll run the application, we'll be able to fill in all the information, but then it'll throw an error saying create user request has a password that users does not have. So for this user specifically, we will not be able to use this trick of .dictionary. We will have to open up the parentheses and type out everything inside. So here, let's just go ahead and say email equals create user request.email. Username equals create user request.username. First name equals create user request.firstname. Last name equals create user request.lastname. Role equals create user request.role. Just for this example, let's go ahead and just say hashed password equals our create user request.password. And then we want to say is active is equal to true. And we can see that we get all of this information, which is 1, 2, 3, 4, 5, 6, all from our create user request, which also has 6 pieces of information getting passed in. We're not yet hashing our password. We're just going to save it as plain text. And then is active is equal to true. Now, just so we can see this, let's go ahead and just return this create user model back when we call this API endpoint. Let's open up our terminal and make sure our application is running. And then let's open up our browser. And then let's refresh the page. And here we can see that we now have a create user / authentication. If we come in here and we just say some demo information like username is coding with Roby, email is coding with Roby at email.com. We're going to say first name is Eric, last name is Roby. And let's say the password is test1234. And let's say the role is admin. If we execute this, we can see that we get a status code of 200 back, and we'll need to change that. But we will get all of the information back. So we'll have a new user model that has a username of coding with Roby, email coding with Roby at email.com. First name is Eric, last name Roby, password test1234, and the role is admin. So this is exactly what we wanted to show in this video, is how to create a new user model. And I'll see you in the next video where we start hashing this password to get one step closer to being able to save this information as a record in our database. And I'll see you in the next video. Hey everybody, in the last video, we went ahead and added our create user Python function from our API endpoint of /auth. Now, this is looking really good, except for the fact that our hash password is actually just the plain text that the user passes in with the request. Now, what we want to do is hash this password. Therefore, if a user says their password is going to be test1234, we don't want to just save test1234 into the database. What we actually want to happen is for us to hash this password. So if we get test1234, we hash it using something called bcrypt, and bcrypt is a very popular way to hash text. Therefore, after we hash it, we're going to get something crazy like a long string of characters that is no longer resembles test1234. Then when we save that into our database, it's going to be this hashed password. Then if a user wants to log in, we'll get their new text, rehash that, and see if it matches the hash that we have saved in the database. This is to protect for all types of different types of security and getting hacked or getting your database leaked that users' passwords are not released to the public. All right, so the first thing I'm going to do is just stop the terminal by pressing Control C. And now we need to install two different dependencies. The first dependency is going to be passlib, so we can do pip install passlib. And now the second dependency is bcrypt, but we need to make sure that we install a specific version of bcrypt, and that's because of how passlib and bcrypt work together. Now, I don't want you to think this is like we're downloading and installing old technology or anything like this. This is the modern way to be able to do this using passlib and bcrypt. So what we need to do is say pip install bcrypt == 4.0.1. Now, this is really, really important. You will break your application. So make sure you do pip install bcrypt == 4.0.1. If you do not do this part, your application will break and it'll say like you have an error of __ about. You just want to do pip install bcrypt == 4.0.1. All right, and now if we just make that smaller. All right, so now passlib was installed into our application. So if we scroll all the way up to the top, we can now use passlib in our application. So let's go ahead and say from passlib.context, import crypto context. And now passlib has a bunch of functionality inside, but really all we're going to be using it for is for encrypting and hashing passwords. Now, after we import this, let's go right under our router, and we now need to create a new variable that is going to use this crypto context as a bcrypt. So let's go ahead and say bcrypt _ context equals our crypto context. And inside here, we're going to pass in two things. One's our schemes, which is equal to bcrypt, and the other one is deprecated to auto. Now, we don't really need to know what this means. It's just some setup information and default information that we need for our passlib to work properly. But you'll see the bcrypt context in action in just a little bit. All right, and now, for example, inside our bcrypt context, we can now use our hashing algorithm of bcrypt. Now, if we scroll back down to our create user, we can see that we have this hash password that's equal to our user request.password. Now, instead of this, let's go ahead and just remove all of this information. And let's say hash password is equal to bcrypt.context .hash. And now inside our hash, we're going to say create user .password. So our hash password is going to be equal to whatever bcrypt context.hash returns from this create user request.password. Now you might be thinking, what is this hashing algorithm that's going to be happening that transforms our text into some long string? Well, no one really knows. If people knew the bcrypt hash, well, then it wouldn't be all that successful because then people would be able to dehash a lot of different passwords that might get leaked. So your average developer, me included, do not know the algorithm that goes into this that actually encrypts the password itself. So now if we come back into here and we start up our server by saying uvicorn main :app -- reload. And we're right here. We can go to create user, say try it out. And let's type some information back in here again. So username is going to be coding with Roby. Email is going to be codingwithroby@email.com. First name is going to be Eric. Last name is going to be Roby. Password is going to be test1234. And role is going to be admin. All right, so remember that we have test1234 as the password. If we go ahead and say execute, and we scroll down, we can now see all this information looks correct, and now our hashed password is this crazy string that no longer looks like test1234. And this is what we're going to be saving into the database. So now if a user tries to log in with test1234, we're going to hash that password and see if it matches what we have in the database. If not, well, that means that password is not correct. If it does equal this, well, that means what the user typed in is correct. And that's how we're going to be doing validation and authentication with our application. All right, so in this video, we were able to successfully hash a password, and I will see you in the next video. Now that we have our create user that will take in a create user request, and we can create a username, an email, a first name, last name, a role, a hashed password based on bcrypt, and is active is true, we now want to save it to a database, this specific user, instead of just returning this model back to the client. So just like we did in our to-dos, we want to grab our DB dependency, which calls our getDB that's right above. So let's go ahead and copy all this and go back to our auth. And right under our class of create user request, I am going to drop in this getDB and our DB dependency. Now let's hover over session local and say from database import session local. We then want to import annotated from typing, session from SQLAlchemy ORM, and depends from FastAPI. So if we go up to the top and remove these empty spaces, we can see that annotated is from typing, API router, and depends is from FastAPI, base model from Pydantic, session from SQLAlchemy.orm, session local from database, we have our users from our models, and we have our crypto context that we're using for hashing from passlib.context. All right, and then once we have all that, let's go up to our router.post, and let's go ahead and say comma status code. And from here, we want to say status, which we need to import from Starlight. And we want to say .201 created. We then, as the first parameter, want to pass in our DB of type DB dependency, which is our dependency injection for our database. And I'm going to click enter just to make it easier to see on the screen, but all we're doing is putting the next line, which is our create user request, underneath our DB dependency. And now, instead of returning our create user model, let's go ahead and just say db.add our create user model, and then db.commit. This will call the transaction to the database to add our create user model. Let's go into our terminal and say uvicorn main:app -- reload. And we can see our application startup was complete. Let's open up our browser. We have our create user, and I'm just going to paste in our last request of username is coding with Roby, email is codingwithroby@email.com. First name is Eric, last name is Roby, password is test1234, and the role is admin. If we click execute, we're going to get a 201 with a response body of null. And if we go back to our application, we don't have any API endpoints that can validate if a user is in here or not. So I'm going to just close out of this, and I'm going to say SQLite3 to-dos app.db. And from here, I'm going to say select asterisk, and the asterisk means all. So select all from users, semicolon. And if I run this, we can see we have a primary key of 1, an email of codingwithroby@email.com, a username of codingwithroby, Eric Roby as first name and last name, our hashed password, the user is active because 1 is true and 0 is false, and this user is an admin. So this is awesome stuff. We were able to go ahead and now create our DB session and instance, which is our dependency injection for our post request method to be able to create a user. We create a new user model and then save it to our database. All right, this is awesome stuff. We now have a fully qualified user in the database. Now let's jump into some authorization and authentication so we can validate when a user logs in that this user is a real user so they can start dealing with our to-do API endpoints. And I will see you in the next video. Now that a user is able to submit a username and password and we're able to hash the password and save this user as a record in the database, the next thing we need to do is allow a user to be able to authenticate themselves so they can sign in as this user that we saved in our database. Now, to do this, we're going to break this over a couple different videos so we can really understand and grasp the idea of how authentication and authorization is working in FastAPI. Now, let's scroll all the way to the bottom and let's create a new API endpoint. This API endpoint is going to be a post request method with a path of /token. Now, a token is what we're going to return back to the user that's going to have all of the information about the user inside. And this token is going to be a JWT, which is a JSON web token. But before we really dive in there and create a new JSON web token, let's go to step 1, and that's just being able to receive the information that a user submits. So right here at the very bottom, let's go ahead and just say @router.post, and as the path, we'll say /token. And then we'll say async def login for access token. And then let's go ahead and just say return token. And now let's go ahead and say unicorn main:\app -- reload. Let's then open up our browser. And here we can see our new API endpoint of /token login for access token. Well, when we open this out and we say try it out and execute, we can see that we will in fact get token as the response body. However, there's no way for us to be able to input a username or password to this specific API endpoint. Well, let's go ahead and do that right now. If you do not already have Python multipart installed on your virtual machine, we will need to do that right now. So I'm going to close out of our terminal and I'm going to say pip install python-multipart. Once you do that, we can now submit forms to our application, but we're not going to be using a normal FastAPI form. We're going to be using something called OAuth2 password request form. It's a special kind of form that will be slightly more secure and will have its own portal on Swagger, where we will be able to get the username and password for the request. So right here at the bottom of our imports, and let's go ahead and say from fastapi.security import OAuth2 password request form. Now, once we import this request form, we now need to use it as a dependency injection for our API endpoint. So let's scroll all the way down to our API endpoint that we just created. And let's go ahead and say form data annotated. And then we're going to say as brackets OAuth2 password request form, comma depends. And then we also want to add our database, so we can say DB of type DB dependency. All right, now just by adding this annotated OAuth2 password request form, if we go back into our terminal and we say unicorn main:\app -- reload, and we go back to our browser and refresh the page, we can now see that this /token of login for access token will now take in a lot more information. It's going to take in a username and a password. So if we say try it out and we type in anything we want for the username and password and we say execute, we can see that this will be successful. Because we are taking in a username and password, but we're not validating the username and password in any way. We're just consuming this username and password as an OAuth2 password request form. And then we're returning this token because we're saying that this function relies on our form data, which has a dependency injection of OAuth2 password request form. Now, the OAuth2 password request form is going to have a couple different variables involved. It's going to have everything we see here, which is grant type, username, password, scope, client ID, and client secret. But all we need to use here is a username and password. So if we go back down here and we say we want to return our formdata.username, and we save the application and then go back to our browser, and we re-execute this API endpoint, we can now see that we're going to get A as a response because that's the username we're passing in. So it is going to get the username and password that we are submitting with our OAuth2 password request form. Now, the next thing we need to do is, based on this username, go ahead and fetch the user. So what we want to do here is let's go ahead and just create a new method that is going to take in our username, our password, and our database that we have already started up for this session. So I'm going to scroll up to the top above our first dependency and just create a new Python function. This Python function is going to be called Authenticate User. And we're just going to say def authenticate user, and we're going to pass in three things. We're going to say our username of type string, our password of type string, and our DB that we're passing in from the session that we created already from the API endpoint. So here we can now query the database. We can say user equals db.query and pass in the users. And say we want to filter by our users.username, which is going to be equal to the username we're passing in. And then grab the first response. We then want to say if not user, so if the user is none or empty, return false. And then we want to verify that the password is correct. So then we can say if not, bcrypt context.verify our plain password and hashed password. Then return false or return true. So what we're saying here is we have a new function that takes in a username and a password and our database session. We then query for the user based on the user's username, which is a unique value. If we get nothing from the database, we're going to return false. And if we run this bcrypt context.verify, which takes in our password that the user just submitted, and it checks the password, which is the hashed password of what's in the database. So bcrypt is going to automatically hash this password and see if it matches this user hash password, which will tell us if the user's password is correct or not. If it's not correct, we're going to return false. And if the user is valid and it has the correct password, we're going to return true. So let's scroll back down to our application And let's go ahead and call that function. So right here, let's go ahead and just say user equals authenticate user form data.username form data.password and our DB. And here we can say if not user, return failed authentication. Or let's just return successful authentication. Let's save the application and go back into our terminal, make sure the application is running. Let's open up our browser. Let's refresh the page. I'm going to say try it out, and I'm going to pass in A and A again, so our username and password. If we say execute, we're going to get failed authentication, and that's because we're just passing in A and A as our form data. So when we call our authenticate user function, we are not able to identify the user, which then fails the authentication process. If we pass in a user that we know the username does work out, like coding with Roby, and we pass in the same password of A, and we say authenticate, we're going to get another failed authentication. And that's because we do get a user, but our bcrypt context of verifying is failing because what we hashed was test1234, not the letter A. So let's do it one more time, but with the correct password. So test1234. If we say execute here, we can see that we get successful authentication. And that's because we're passing in the correct username and password, we're finding the user by their username, we're then validating that the password the user types in matches the password of the user within the database, and then we return true. So this means this is now going to be true, which means return successful authentication. Now we still have a lot more steps we need to go through, but this is step 1 of how to authenticate in FastAPI. So congratulations, and I'll see you in the next video.
Hey everybody, and welcome back to another lecture with Coding with Roby. In this lecture, we will be going over JWT, which stands for JSON Web Token. JWT is one of the most popular bearer tokens and authorization protocols within APIs. So this is a good chance to get familiar with JWT. What is a JSON Web Token? Well, to start, a JSON Web Token stands for JWT. JSON Web Token is a self-contained way to securely transmit data and information between two or more parties using a JSON object. A JSON Web Token can be trusted because each JWT can be digitally signed, which in essence allows a server to know if the JSON object has been changed at all from the client. JWT is not an authentication method like Basic and Digest, but an authorization method in which allows the client and server to maintain a relationship without having to log in each request. JWT is a great way for information to be exchanged between the server and client. Once a user logs in, the server will return a JSON Web Token, which is a string of characters that when decoded shows information about the client and user. Each time a request comes from the same client after a successful authentication, the client will send the JSON Web Token, and the server will validate the token each request. All JSON Web Tokens have similar structures. A JSON Web Token is created by 3 separate parts separated by dots. The JSON structure includes a header, a payload, and a signature. Therefore, a JSON Web Token being sent between the client and the server may look like the image, but instead of A's, B's, and C's, those will be unique characters for that specific client. The JWT header is the first part of a JSON web token that is sent between the client and server. The JWT header usually consists of two parts: the algorithm for signing and the type of token. The JWT header is then encoded using base64 to create the first part of the JSON web token. As we can see, the multiple A's of the image below is the first part of the JWT. This image is displaying an example of where the JWT header lies. The JWT payload is the second part of a JSON web token. A JWT payload consists of the actual data of the user and/or additional information. The payload's data contains claims, and there are three different types of claims. These claims include register, public, and private. Registered claims are claims that are predefined, recommended, but not mandatory. The top three registered claims include ISS, SUB, and EXP. ISS stands for issuer. This claim identifies the principal that issued the JWT. SUB stands for subject and holds statements about the subject. The subject value must be scoped either locally or globally unique. Think of a subject as an ID for the JSON web token. EXP stands for expiration time, which is when the JWT expires. This claim makes sure that the current date and time is before the expiration date and time of the token. Expiration is not mandatory, but extremely useful. One thing you never want to do is have your token never expire. This is because if your token never expires, then anyone who has a JWT will be authorized by the server. You will always want to make sure there is some type of default expiration date attached to the JWT. I've seen different types of expiration times attached to JWTs. The one I used the most recently had an expiration time within an hour of no activity from the client. Therefore, if the user does not do anything within an hour, the JWT becomes invalid. The JWT payload is then encoded using base64 to create the second part of the JWT. From the image below, we can see that the B's are the JWT payload and happens after the A's, which is the JWT header, and is separated by a dot. A JWT signature is the third and final part of a JSON web token. The JWT signature is created by using the algorithm in the header to hash out the encoded header, encoded payload, and secret. The secret can be anything, but is saved somewhere on the server that the client does not have access to. The signature is the third and final part of a JWT. From the image below, we can see that the C's are after the JWT payload and separated by a dot. This is where the signature goes. So to recap, the JWT's components include a header, payload, and signature. Let's now look at a JWT example and add all the different components together to see what we get. First, let's create the JWT header. This is a JSON object which holds alg, which is equal to HS256 algorithm, and the type of token, which is JWT. We then have the JWT payload, which has a subject of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, name, which is Eric Roby, a given name, which is Eric, a family name, which is Roby, and an email at codingwithroby@gmail.com, and the admin status is true. Lastly, we have the JWT signature, which is the encoded header, encoded payload with a secret. In this example, the secret spells out learn online, and all of this is hashed within the algorithm. With all of this combined, you get the JSON Web Token string. This string is completely unique to the client based on the authentication of the user that has logged in. When working with a JSON Web Token, the requester usually sends the token in the authorization header using the bearer schema. This is a different schema than the basic authentication and digest authentication that we learned before. Now, with all security measures within APIs, never send sensitive data back to the client. However, the JWT is safe as long as the client does not find out the secret key, which in this example is learn online. If the client was able to discover the secret key, they would have so much more control over the data. If you visit https://jwt.io, you can encode and decode your very own JSON Web Tokens. You can see I typed in the header, payload, and signature to match the example on the last slide. In return, we get the encoded JWT. If any of the information on the JWT has changed, the server will be able to identify that something was altered. For example, let's try removing a character from the secret on the encoded side. Immediately, we are shown an invalid signature. This is because I removed the last character out of the signature on the encoded side. This is why JWT is so popular when dealing with authorization. It is because of how quickly the server is able to identify data that has been altered. So what are some JWT practical use cases? Now, there are multiple different scenarios in which JWT is an amazing option for authorization. However, imagine this scenario. A single company or enterprise has multiple different applications that many different users work with. For example, let's say you want to get into cryptocurrency, and App 1 is the cryptocurrency market where you can buy and sell many different types of cryptocurrencies. Let's say the same company that owns App 1 also has another application where you can store cryptocurrencies in a digital wallet. Now, if you are the company that owns both applications, you do not want your user to have to sign into one application to buy cryptocurrencies and then technically have to sign into a completely different application to move their cryptocurrencies into a digital wallet. It would be a much better experience if the user did not even know that there was two separate applications, and that the user experience between the two applications were not even noticeable. This is possible if App 1 and App 2 share the same secret. This means both servers would be able to handle decoding the JSON Web Token and know exactly who the user is that is trying to perform the action. Using JWT is extremely popular in modern architectures like microservices, where each API may be loosely coupled and in some cases completely stateless but require user information. These microservices or micro APIs can find the user by decoding tokens and never having to implement authentication or authorization within the specific API. I know this was a bunch of information, but I hope this gave you an amazing insight into how JWTs and authorization is working in the modern technology era. This wraps up this lecture on JWT, and I'll see you in the next video. Alright, so we ended the last video with creating this token API HTTP request where we can pass in a user and we can validate if the user is actually in the database and validate the password so we can have a failed authentication or a successful authentication. In this video, we are going to return a JWT if the user is authenticated, or we're just going to return failed authentication. So the very first thing we need to do to be able to create a JWT, a JSON Web Token, so we can return a token that'll say if you're authenticated or authorized, is first we need to install a new library. This library is going to be pip install double quotation marks python-jose brackets cryptography.
Now, once you install that, that'll give us some functionality to now be able to return a professional JWT back to the client. So to start, let's go ahead and just say from JOSE import JWT. Now, a JWT needs a secret and it needs an algorithm. So right under our router, let's go ahead and just add our secret key and algorithm. So our secret key, I'm going to say in all capital letters, and I'm going to say this equals a long string. Now, this can be anything you want. Just to make it unique, I'm going to open up my terminal and say open SSL rand-hex 32. This will return a long string back to us, and I think that's pretty secretive. It's something extremely unique. And then let's go ahead and say algorithm equals HS256. Now, the secret and the algorithm will work together to add a signature to the JWT to make sure this JWT is secure and authorized. So these are extremely important to have with a JWT. Just remember that with each JWT, we need a secret for our application and an algorithm where we're typically going to use the HS256. All right, so now let's scroll down until we can see our one function that does not have an API endpoint, which is this authenticate user. And right under this authenticate user, let's create a new function. And this function is going to be called create access token. And we can do this by saying def create access token, where as the parameters, we're going to pass in username of type string, user ID of type int, and we're going to say expires underscore delta of type time delta. We can go ahead and just say import time delta from date time. So if we scroll back to the top, we can see that from date time, we've imported time delta. All right, so moving right along, let's go ahead and now create the encoding, which we want to add to our JWT. So it's going to be like the information that lives inside the JWT. We can dictate that right here. So we can say encode equals, and we want a dictionary, so we want each to have a key value pair, sub of type username, and ID of user ID. So when we get a JSON token, we can now decode this JWT if it's authenticated, and we can find the username and user ID. However, we also want to find the expires delta, so when this token is no longer authorized. So each token is going to be able to be expired. So we can say expire equals datetime.utc now, and we want to make sure that we import datetime from datetime. So if we go back up to the top, both time delta and datetime are from datetime. .utc now. Now, just a quick update, datetime.utc now is deprecated. And we need to change this a little bit, but the change is not worth, changing the whole video. And what we need to change it to now is datetime.now. And then in parentheses, we're going to pass in timezone.utc. Now, the only difference here is we also need to import time zone from datetime above. But then once you add this, just follow the rest of the video, everything will work correctly. But instead of datetime.utc now, we want to say datetime.now and pass in timezone.utc. Plus expires delta, so whatever we pass in as the parameter, we're going to add to the end. And then we can update our encoding by saying encode.update exp, which is expire of type expire, And then we can just return our JWT.encode. So this is the JWT that we just imported. We're going to encode everything and pass in our encoding, which is everything that's inside, our secret key, and our algorithm, which is equal to our algorithm. All right, so now we can scroll back down to our login for access token. And right under if not user, we want to say token equals create access token, where we're going to pass in a user.username, a user.id, and our time delta that's equal to 20 minutes. And now let's just go ahead and return this token. So let's open up our terminal and say unicorn main:\app --reload. Open up our browser, refresh the page. I'm going to say try it out. I'm going to say coding with Roby and password test1234. And I'm going to say execute. And it looks like we might have got a quick error, so let's go take a double look. Got it. So right above where we did our authenticate user, we are returning true and we need to return user. So right here, if not user and if not bcrypt, we want to return our user. So now let's go back to our browser and let's execute again. And here we can see that we get our token back as the return. Now, one more thing that we want to do in this video is we want to add more information back instead of just returning the token as a whole. So let's scroll up and right under our create user request, let's create a new class, this one called token, and we can say class token base model, and we'll pass in base model, and we're going to say access token of type string and token type of type string. And now let's scroll back down to our login for access token. Here at the top, we're going to say our response model is equal to token. And then we're going to return a dictionary because we want to make sure that the user knows it's a bearer token. So let's go ahead and just say brackets. Access token is going to be our token. And token type is going to be bearer. All right, now make sure your terminal is running. Let's go back to our browser, refresh the screen. Say try it out. Type in coding with Roby and test1234. And here we can see that we get our token model with our access token and our token type. And with that, we now have a full functioning JWT. If we grab this token and we go to jwt.io, we can scroll down and we can paste in our token right here. And we can see that we're using the algorithm of HS256. Type is JWT. Sub is coding with Roby. ID is 1. In the expiration of this token in the future. So just with that, we now have our FastAPI application returning a JSON web token, and I will see you in the next video. All right, so in the last video, we encoded our username and password with our secret and algorithm to be able to create a JWT. Now in this video, we are going to learn how to decode a JWT. And now decoding a JWT is going to be used often in this course because that's the only way to be able to verify that a JWT is authenticated. So let's just recap. When a user logs in, we pass in the username and password, we return a JWT, and now each API endpoint that needs security or authorization, we're going to verify the JWT that the client is going to pass in to make sure that it's secure and it hasn't been messed with. Well, just like we did from our FastAPI security, we imported our OAuth2 password request form. We're going to want to import OAuth2 password bearer. In the header of every API endpoint, we're going to be passing in this bearer token, which is a JWT, and we're just telling FastAPI to check the bearer token in the header for this JWT before we process the request. So after we import this, we need to come down here and right under bcrypt context, we need to create a new dependency that each API endpoint will rely on. And here we'll call this the OAuth2 underscore bearer, which is equal to our OAuth2 password bearer. And we're going to pass in the token URL as token. Now this parameter contains the URL that the client will send to our FastAPI application. So we need this just to verify the token as a dependency in our API request. Now, the function that we're going to create is not necessarily going to be an API endpoint. It's going to be used as a way for other API endpoints to be able to verify the current user. So right under our last regular Python function before API endpoints, let's go ahead and just create a new Python function, async_def get current user. And as the parameter, we're going to say token of type annotated, brackets, then we're going to say string, and then here we're going to do the dependency injection of our OAuth2 bearer. So again, each to-do in the future that needs security, we are going to call this get current user first to verify the token that's getting passed in as the OAuth2 bearer token in our client call. And I'll show you how to do this in Swagger and all of that. So now let's go ahead and say try, because we need to do a try and exception because this could fail based on the authenticity of the token. Now, the data inside a token is usually called a payload. So let's go ahead and say payload equals jwt.decode. And we're going to decode this token by passing in the token. And then we need to pass in our secret key and our algorithm. Now we need our secret key and algorithm because that's going to also check the authenticity of our token, because a user could just create a fake token, but they must know our secret key and our algorithm to actually be able to create a fake token. So this is all of the steps that we need for security to make sure that our token is true. If it is true and our payload is successful, we want to say username of type string equals payload.getSub. Because we said sub is our username. User ID of type int equals payload.getID. Here we want to make sure that the username or user ID is not invalid. So we can say if username is none or user ID is none, we want to raise an HTTP exception. And we're going to want to import our HTTP exception from FastAPI, where we pass in a status code that's equal to status.http 401 unauthorized. And with a detail that's equal to could not validate credentials. However, if username or user ID is not none, we want to return username of type username and ID of user ID. We then want to say except, and we're going to be using a JWT error, so we can scroll back up to the top and just import JWT error. And if we get a JWT error, we just want to throw the exact same HTTP exception as above, so we can just copy and paste that in. Now, since this is not an API endpoint, we're not going to be running this right now, but we're going to be using this in the next few videos. So I will see you in the next lecture where we go over how to now pass in a JWT token so we can have security and authorization within our application. All right, in the last video, we went ahead and created this OAuth2 password bearer, and we were able to now get the current user. And then in this video, we're just going to do some minor cleanups for our auth.py file. The very first thing we're going to do is scroll down, and as soon as we see this raise HTTP exception, let's go ahead and just grab this. And let's scroll down a little bit more right here until we can see our /token HTTP request. And right here where we verify if the user is false, and we just return a string that says failed authentication, let's go ahead and just paste this HTTP exception of a status of 401 unauthorized and could not validate user instead of just returning that string. All right, and now the next thing we're going to do is if we go back to our application, we have our /auth create user and we have our /token login for access token. However, we also have all of our to-do API endpoints all in one line within our Swagger documentation. Well, let's divide these a little bit so we have our authentication API endpoints together and our to-do API endpoints together. So let's close out of this and let's go back into our application. And right here where we say router equals API router, let's go ahead and just open this up. And let's go ahead and say prefix equals /auth with a tag of auth. So what this is going to do is we are now going to divide our application with a new title of auth that'll show all the auth APIs. And then each API endpoint within this auth.py file is going to start with /auth. So if we go ahead and save this application and we reopen our Swagger UI and we click refresh, we can now see that it says auth, and that's based on our tags, has our two API endpoints, and each endpoint starts with auth. Now our create user of auth/auth is kind of redundant, so we can just go back and let's go ahead and fix this by scrolling back down to our post API endpoint where we create a user, and let's just remove this beginning slash because we are already adding a prefix of auth. Let's go back into our application, refresh. We can see that create user is /auth, and now our login for access token is auth/token. And just one more thing we need to do after changing our prefix to /auth. Let's scroll down until we can see our token, and let's go ahead and just say auth/token. Now, when we check the header for our JWT, we are going to be looking in our OAuth to bear token spot, and we're going to validate against our /auth token, which will successfully call our token API endpoint when we need it for our dependency injection. And again, I'll show you this in an upcoming video. So this is exactly how we do JWT and OAuth 2 bear authentication and authorization in FastAPI. And I will see you in the next video where we dive into our to-dos and start implementing some authorization to validate that a user has successfully logged in before accessing specific API endpoints.